Okay, this is Katie Bowman's AP problem number 10. We'll start by reading the question. A student prepares 100 milliliters of a saturated solution of MgF2 by adding 0.5 grams of the solid MgF2 to 100 milliliters of distilled water at 25 degrees Celsius and stirring until no more solid dissolves. Assume that the volume of the undissolved MgF2 is negligibly small. The saturated solution is analyzed, and it is determined that the concentration of F minus in the solution is 2.4 times 10 to the negative 3 molarity. Part A, the first part of it asks, write the chemical equation for this dissolving of solid MgF2 in water. So we go to the back, and this is my part A. We have our MgF2, our double arrow, and then it's Mg2 plus 2F minus, and the coefficient 2 is here because we had to balance it out because the charges are different. Alright, so the second part asks, calculate the number of moles of the MgF2 that is dissolved. So you start with taking the molarity of the F minus that they initially gave you, and you're going to convert it into moles by multiplying it by the total liters, and then you'll do a multimole ratio from using this to convert it into MgF2. So you'll use 2 moles of F minus under 1 mole of MgF2, which equals 1.2 times 10 to the negative 4 moles of MgF2. So then part 3 asks, determine the value of the solubility product constant KSP for MgF2. So for this, our KSP is going to be the concentration of Mg times the concentration of F minus. So we already have the concentration of F minus here, so we need to know the concentration of Mg. And when you look at the equation, we know that Mg is half the amount of F minus, so we can multiply it by 1/2 or divide it by 2 to find the concentration of Mg. So that gives us 1.2 times 10 to the negative 3. So we can plug that all in here, and that gives us 6.9 times 10 to the negative 9. Oh, and for the KSP, F minus has an exponent of 2 because the coefficient is 2 here. So you'll include that into your KSP equation. So then part B says, a beaker contains 500 milliliters of a solution in which both Ca2 plus and Ba2 plus are present at a concentration of 0.1 molar at 25 degrees Celsius. A student intends to separate the ions by adding 0.2 molar NaF solution 1 drop at a time from a burette. At 25 degrees Celsius, the value of KSP for CaF2 is 3.5 times 10 to the negative 11. The value of KSP for BaF2 is 1.8 times 10 to the negative 6. Part 1 asks, which salt will precipitate first, CaF2 or BaF2? Justify your answer. So CaF2 will precipitate first because its KSP value is smaller. So it'll run out faster and it'll make a precipitate. So then part 2, so little side note it adds is, for part B2 and B3 below, assume that the addition of the NaF solution does not signify effect by total volume of the liquid in the beaker. So part 2 says, calculate the minimum concentration of F aqueous necessary to initiate precipitation of the salt selected in part B, the first part of part B. So you're gonna do KSP equals 0.1, which is where the concentration that it gives us somewhere in here. Oh yeah, the concentration of Ba, which is 0.1. So it's going to equal F minus 2. So you'll divide both sides by 0.1, and then to get rid of the exponent of 2, you'll square root both sides, and then when you square root this, it gives you 1.9 times 10 to the negative 5 molarity. So then part 3 asks, calculate the minimum volume of 0.2 molar NaF that must be added to the beaker to initiate precipitation of the salt selected in part 1. So for this one, you're going to do M1V1 equals M2V2. So you use 0.2 for your concentration, and you're finding the volume for this part, and then you'll use what you figured out for F, the concentration of F minus from up here. You'll put that there, and then 0.5 liters. And when you do that math and divide over, your volume is 4.7 times 10 to the negative 5 liters. And then the last question says, there are several ways to dissolve salts that have a limited solubility. Describe one procedure to redissolve the precipitate formed in part B. So what you can do is increase the heat you can increase the heat, which will increase the collision rate of the reaction. So the molecules will start moving faster, and it will make them dissolve quicker. So that's it.